and welcome back to Algebra 1. Our goal for today is to look at how to use our prime factorization using our factor trees to get to a prime factorization statement for an individual term or what's called a monomial so that it can help us calculate the least common multiple of two or more monomials or terms or the greatest common factor of two or more individual terms or monomials. So again, the tree that we were working on in previous lessons deals with how to break down our numbers. It's a skill that's necessarily something that's important by itself, but it's a skill that helps us do other tasks. So for today, it's LCM and GCF. So least common multiple and greatest common factor. So yesterday we looked at, or in previous days learning, we looked at how to take a value and break it down to its prime factors. So for today, when we go to use our prime factorization to help us calculate our least common multiple or our greatest common factor, we're actually going to use this not all the way completely done version, where we see every individual item, not this best possible prime factorization statement we were writing yesterday or over the last couple of days. So when we go in and we get down to this portion where we have all of our individual prime items, that's what's going to help us calculate our least common multiple and our greatest common factor. Same thing when our original item starts with variables. We're going to use this huge, long, extended version where we can see all the individual terms, not this best possible prime factorization statement. Now, with that being said, if I ask for the prime factorization of something, you should give me this best possible one. If I am asking you for the LCM or the GCF of two or more things, then you want to use this not all the way simplified version to help you get that value, right? Two separate tasks. And for whatever reason, once we go to LCM and GCF, when I ask for this task of prime factorization, we tend to stop here instead of getting this best possible version. So just be careful. They're two sort of separate tasks. So our goal for today, what's called using prime factorization to get a GCF or LCM. So putting on our elementary hats here for a second, you calculated greatest common factor and least common multiple way back like fourth grade. And the way that you did that was factors are numbers that divide the given number without a remainder. So, for example, 5 and 10 are factors of 50 because they go into 50 evenly. So if we took 50 and divided by 5, we get a perfect number with no remainder or decimal. If we took 50 and divided it by 10, right, it goes into it perfectly without a decimal or a remainder left over. So here's the rule for factors. Factors are fewer. I need to remember that. Factors are fewer. Factors are fewer. Put it in your brain. Factors are fewer because they are numbers that are smaller than the original number that go into it. All right, that's what a factor is. It's a number that is smaller to or equal to the original number that goes into it perfectly with no remainder. So if I ask for what's called the greatest common factor, or GCF, you're looking for the largest number that goes into both or all three of the original numbers evenly without a decimal or remainder left over. So for example, if I said, what's the greatest common factor of 24 and 60? We can make a list of all our factors of both, right? So our factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. And it's fairly simple to do because 24 is not that big of a number and it doesn't have that many factors. And then we could say the same thing for 60. What are our factors? There are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. And then your greatest common factor is the highest one they have in common or the highest one that they share. So in this case, 12 is the highest one that's in both lists. That's the greatest common factor. Now, this method works when our numbers are fairly easy and simple to work with and when they don't share a variable. So when we go to today's problems, they're going to be a little bit more complex than these, and they'll include some variable parts. So our goal for today is another method that gets us to our greatest common factor that doesn't require us to know all the individual factors that go into that number, right? Because if I, for some reason, when I was breaking down 60, if I accidentally left this one off the list, I made a mistake, I just didn't think about the fact that 12 goes into 60, then I would have said that 6 was the greatest common factor. And although I took the time to really make a list, I just made a little mistake along the way, which made me misidentify the greatest common factor. So we need a second approach that helps us so that we don't have to know all that whole list of factors. That's our goal for today. Now, same type of idea for least common multiple. All right, multiples are the product of a number and any non-zero number. All right, so now get this in your head, right? For factors are fewer, so multiples are more. Multiples are more. Multiples are more. I got to remember that multiples are more. So multiples are when I take my original number and I multiply it by something, what would be the result? So for example, if I was working for multiples of 5, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. The 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, on forever are the multiples. All right, so when I take a number and I multiply it by another number, I get what's called multiple. Multiples are more. They are going to be equal to my original number or bigger. All right, that's going to help me when I go to do my work today. All right, so if we wanted a least common multiple of 8 and 12, again, I could do the list approach and I could start to list all the multiples that I have. So for 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and so on, all right, 88, and on and on and on. All right, 12, 24, 36, 48, 60, 72, and so on. So for least common multiple, I'm looking for the first or the lowest one that they have in common, in this case, the 24. Again, this listing method is easy when the numbers are simple like this, but our problems are going to have variables attached to it, which makes it tricky. So our approach for today is, how do I get this lowest one they have in common when there's also letters and things like that? Or my numbers are more complex and harder to work with. So our goal for today is a second method other than listing. So I won't see any problems where you're listing for right now because you're going to use what I call the chart method. I might be able to do some of the simpler ones using the listing method, but for right now, we're practicing the chart method to get our least common multiple and greatest common factor. So that's what you're going to show me on your work today. All right, so we're going to make a factor tree for all the given original what are called monomials, which is a fancy word for one individual term. Once you break down your individual terms or monomials, you're going to take that prime factorization and put it into a chart, and you're going to put it into a chart in a specific way. So I'll make sure that we understand that. And then you'll follow these rules to get your GCF and LCM. All right, so factors are fewer, factors are fewer, factors are fewer. Put that in your brain. So for GCF, I'm using fewer things from my chart. So again, factors are fewer, so I'm going to use fewer things from my chart. And I'm only using columns that are completely full in my chart to get GCF. Every column that is completely full is one number I have to multiply to get my GCF number. Final answer. All right, for LCM, once I have my chart, multiples are more, multiples are more, multiples are more. Put that in your head. I'm using more stuff from my chart. So I use every column I have a number in my chart. I have to take every single column that has a number and multiply it to get what's called the LCM, or it'll give me the result of the least common multiple of the original values. So factors are fewer, multiples are more. That's going to help you as you work through your problems. It's a way to check your final result, and it's a way to remember how much am I using from my actual chart. All right, so a couple different scenarios. This is not in your packet, but this is what we're going to end up with when we make our chart. Something that looks like this, where the top, right, this whole top row represents our first thing we broke down with our tree. And this whole entire bottom row represents the second thing that we broke down with our tree. And then we took their prime factors and we put them into a chart. And more specifically, we put them into a chart. If I put a 2 here, I'm only allowed to fill in that bottom block with something that identically matches it. So this first one was 2 times 2 times 3 times 7 times 8. That's the prime factorization. This bottom was a 2 times, don't have another 2, I had to leave it blank. 3 times 5 times, don't have a 7, I had to leave it blank. Times A times B times P was its prime factorization. So once I have my chart, Factors are fewer. So what I do with my chart is I use columns that are completely full. Columns are going this way, up and down. All right, so this is a column that is completely full. It represents one thing I have to multiply down here to get what's called the GCF number. All right, this column is not full, so I will not bring down a second 2 here. All right, this column represents one number, 1, that comes down here and gets multiplied for our GCF. This column is not full, so no 5. This column's not full, no 7. And the reason is they have to be common factors, right? It has to be things that they have in common here. All right, so they don't have a 5, a 7, and an extra 2 in common. All right, so A is a common factor. It's going to come down here. B and B is not a common factor. It's not going to get multiplied. Right? So in this case, 2 times 3 times A would give us our greatest common factor of those two original numbers. And we'd end up with 6A is our common factor. Now, multiples are more, multiples are more, multiples are more. Get that in your head. I'm using more for my chart. So I'm using these columns that are full, right? I'm still using 2, 3, and A, but I have to use every column now because I have to multiply everything that they have to multiply, which is a little bit confusing, right? So remember, I'm going to end up with something equal to or bigger than my original numbers. So every single column here is something I have to multiply. So a 2 times a 2 times a 3 times a 5 times a 7 times an A times a B times a B. All right, we'd have to multiply that entire thing, and the result would be our least common multiple. All right, so let's look at one that's a little bit different, where there were 3 original items, because for whatever reason, this messes us up. All right, GCF. Factors are fewer. I'm only using columns that are 100% completely filled up, which means they would look like this, where all 3 of these are filled in, which is different from something that looks like this, where 2 of them are filled in and 1 is empty. If any block is empty in that column, it can't be part of our common factors, called our GCF. All right, so for this one, we have a 2. Nope, nope, nope. G. Nope, nope, nope. Right, we'd end up with 2 times G, or just a 2G here. All right, for multiples, multiples are more, multiples are more. I'm going to use more stuff from my chart. I'm using every column. One column is one number, no matter how many things are in that column. So this is a number, 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 this is a number in my multiply. 2, 2, 3, 7, G, G, K, K. 2, 2, 3, 7, G, G, K, K. And one column represents one thing I'm multiplying, not however many things are in that column, so be careful. All right, 2 times 2 times 3 times 7 times G times K then would give us our least common multiple for this one. All right, so let's go to our packet. Let's look at some examples. All right, our first one is as simple and as easy as it gets because we have numbers that don't have letters. So for this one, you may say, well, Ms. Howell, this one would have been easier to make a list. But I want to show you the method with easier numbers so that when the problems get more complex, we're able to do them. All right, so let's start with our 36. We're going to break it down with a factor tree. All right, 6 and 6 would get us there, and then 2 and 3, which are prime, and 2 and 3, which are prime. All right, I'm not doing anything yet in my chart. I'm going to go over here. All right, 72, 2 and 36. Oh my gosh, now I'm back over here. 6 and 6, 2 and 3. All right, most of the time that will not happen where I get something that matches the other one, right? It just happens to be that 36 is a common factor here. All right, so now I want to fill in my chart the same way I would have written my multiply problem. Start with your smallest numbers and work up to your biggest, and then go to any letters, which this one doesn't have. All right, so I want to start here. This first column would represent if there's any 2s. All right, so this 36 has 2 2s. So up here I would do a 2. Right? Normally I would put a times there, right? It's 2 times 2. Right? That's what we're building the times problem. We're just showing each of the things we would multiply in our prime factorization. All right, I'm going to eliminate up here. And now I'm going to go to the bottom and fill in if there's any 2s for that number. So 1, 2, 3 2s. So I can fill this one in, I can fill this one in, and then there's going to be another 2 up here. This top block needs to stay empty. It needs to stay blank because there was no third 2 for 36. So be careful. All right, now we're on this column, and we can go to our next lowest number in this case, which is a 3. All right, so we have 2 3s up there. So 3 and 3. Gone and gone. This guy's done. 2 times 2 times 3 times 3 gets us back to 36. All right, now on the bottom, we have 2 3s also, so we can put 3 and 3 here. And now that our chart's completely done, we have nothing else, right? We used everything up here. Again, my suggestion up there would be to eliminate like I'm doing, cross them off, so you know you get everything. All right, so in this case, factors are fewer. Factors are fewer. Factors are few. Get it in your head. All right, factors are fewer, so I only use things that are completely full. I'm using fewer stuff for my chart. All right, it has to be completely filled in. All right, so this column is full. That's one number down here. Not 2, it's just 1, 2 that comes down. All right, this column is full, so that's another 2. This one's not, so no 2 for that. This one's full, so a 3 comes down. This one's full, so a 3 comes down. And it's one big multiply, and when we do that multiply, it'll give us the greatest common factor, or the highest number that goes into both 36 and 72. All right, from here, all you have to show me is the result of that multiplication. So 2 times 2 times 3 times 3, which ends up giving us 36. All right, so our GCF for 36 and 72, or the biggest number that goes into 36 and 72 is a 36. All right, now LCM, multiples are more. Multiples are more, multiples are more. I use more stuff from my chart, which is I use every column, even if it's not full. All right, so I still use these 2s, but I have to use this additional 2 I didn't use before. All right, so now we have 3 2s, and I still use these 2 3s, and it's one big multiply that gets us our LCM. All right, so 2 times 2 times 2 times 3 times 3, one big calculator problem, hit times, hit enter, and we'll get a value here of 72. So what does that really mean? Remember, multiples are numbers, the numbers we get when we multiply stuff. All right, so 72 is the lowest number that both 36 and 72 go into, right? That's an LCM. All right, special vocab word we haven't talked about yet with these LCM and GCF things. All right, what's called relatively prime. Relatively prime. Get that keyword, it's a special case. All right, so relatively prime is when 2 or more numbers or monomials or individual terms have no common factors, so the GCF is 1. When the greatest common factor is 1, then we don't say it's 1, we say it's this keyword of it's relatively prime, the relatively prime phone number. All right, so let's look at one. 35 and 54. Again, our numbers are pretty low and simple here, but we want to get how to make our chart down before we go to the ones that are more complex. All right, so up here, 7 and 5 are our prime factors of 35. We want to do that same thing with 54. There's a couple different ways we could get started. 27 and 2, 9 and 3, and this would give us a 3 and 3. All right, now we want to start to build our chart. All right, we want to start with our lowest factor, which is going to be, I'm looking for 2s, right? That's our first prime number, 2. All right, so we have 1 over here for 54. So on our bottom row, we should start with 1, 2. There is none here, so this top block has to stay empty. Just leave it blank. All right, then our next lowest prime number is a 3. There are 3 of them, and they all go on the bottom. 3, 3, 3. Boom, boom, boom. All right, 54 is done. These all have to stay blank, so we're now right here. Our next lowest one is a 5 and then a 7. And these 2 need to stay blank. And then we didn't need this part of our chart at all. All right, from here, factors are fewer. I only use columns that are completely filled up. Nothing here is full, which tells us our GCF is 1, right? 1 goes into 35. 1 goes into 54, which then we say when the GCF is 1, or the only common factor they would have is 1, it gets this description of they are relatively prime. Right, the only time we're writing that they're relatively prime is if none of their factors in your chart are shared or they have them in common. All others, we should be doing the math to get what the greatest common factor is. All right, now, LCM is not affected here because each column gets used for LCM. So this one, right? All these have to get multiplied to get our least common multiple. So 2 times a 3 times a 3 times a 3 times a 5 times a 7. We got to multiply that all out to get our least common multiple. So 2 times 3 times 3 times 3 times 5 times 7. Hit enter, we get 1,890. So the lowest number that both 35 and 54 go into is this 1,890. I hope that helps you get started on your assignment. I'll see you guys later.